Hello guys, welcome to another STM32 tutorial. My name is Edson and today I'll be looking at how you can achieve easy debugging of your code by printing several messages, important messages through the ITM, which is a feature that comes with STM32 Cube IDE. On top of that, I'll be showing you how you can draw graphs of variables in your code. And ITM simply means or stands for Instrumentation Trace Macro Cell. So this macro cell enables applications to write arbitrary data to the SWO pin, which can then be interpreted and visualized in the debugger in various ways. So the ITM can be used to redirect the printf output to a console viewer into the debugger, and that is exactly what we are going to do. So I'll first show you how to redirect the printf function to write messages to the debugger, and also how you can plot graphs on your serial wire timeline graph. And first I'll go ahead and create a new STM32 project, then select the MCU, which is my board is STM32 F407VET 6, and then click next, then give your project a name. I call it SWV printf. So we shall be using printf in this code. So next, then click finish. So from here, what I only need is to activate the clock source. So you go to system code, then under RCC you can enable the high speed clock and the low speed clock. Then from there, go to clock configuration and select the HSE, and I have my oscillator running at 80 megahertz, and I want my core clock to be 168 megahertz, which is maximum. So these are switched back to HSI, but I still want it to remain to HSE. Have these to be 168, and that's right for me. So then go ahead and generate code for your project. So having done that, I'll go to user code begin include. So for the first section of this demonstration, I'll have to include stdio.h, because this is where we find the printf function. And also for the second part, I'll be using the math library, so that we can get the formula to calculate the sine of the angles, so that now you can generate the sine wave. So then from there, go to user code begin 0, and the override function that will be used by the printf is int underscore write, and this guy takes 3 parameters. The first one is the end file, then second one is the character ptr, then the third one is int length, and then inside this function we shall have variable I, int I equals 0, then for I equals 0, then I should be less than n, then we should increment this I. Then for that iteration, I want us to send all the characters to our ITM console. So we select ITM send character, and then the character we shall send is pointed, is a difference of the pointer. Then don't forget to increment this pointer. So then we have return length. So that is a function that we'll be using. So I'll go to the while loop, and in user code begin 3 I'll have a printf function, and I want us to send count is equals to 0, and we can print this in a new line. Then from there we shall have this count value declared, and we want to increment this value by 1, plus we can have a delay of 100 or maybe 1 second. So 1 second. Then maybe we don't want to this value to surpass 10, so we want to get another message if the value goes beyond 10. So that's a way of debugging. So if count, maybe you should first declare this here, int count, and initialize this to 0. So if count is greater than maybe 10, let us now have our count back to 0, and we can have now a different message to print here. So we can print erroneous value here, or simply error found. So that would be good. So let's now build this code to see whether we have any errors. And we have one error, so which is let's see, too many arguments for count. Is that so? Too many arguments for format. So it is count is equals to %d. Sorry, so that is the specifier for this count. So let's build the code, and we have no errors. So from there I'll go ahead and go to debug, and then remember that our core frequency is 168 megahertz. So I'll go ahead and enable the serial wire viewer and have the frequency at 168 megahertz. So then from there can just click OK. Don't worry about the limit SW clock, so click apply, then OK. So then you wait for it to switch to the perspective. And having done that, you can also add this to our live expression. So I'm going to live expression, you add new, I'm going to paste count. So this is where we can see the value of count live expression changing live, and then from there I go to Windows, then show view, go to serial wire viewer, and select the ITM data console. And before we run this, I go to configure trace, and I'll enable the trace, and we can also trace count. And before I say OK, we need to select the ITM stimulus port. So I use port 0 for this. So let's click OK, and then we start tracing. So then I'm going to run the code, and you can see the value is changing here, and also we are able to count. So we want to get the erroneous message. So you can see that we can be able to debug our code easily using this feature. So for the next part, I'm going to generate a sine wave, and I'll be able to plot it using now this feature of the graphical timeline. So let's go ahead and declare a variable. I'll call it I can get rid of this, so I'll call this int angle. So, and I also have a float sine angle, and I'm going to, maybe I can have this to be 0.0. From there, go to this. I'm going to clear all this and have the sine angle is equal to sine of angle times, we have to change this into radians, and 1 degree is equal to 0.17 4532925 radians. So we have converted the parameter to radians. Then from there, I will increment angle. So, and we can check, maybe we can check if we can have the post increment if the plus angle is greater than 360, then we can have our angle back to 0. So angle equals 0, and then after that we have to increment angle. Okay, that's enough because you have already performed a post increment. So from there, let's view this code, see whether we have any errors. We don't have any errors. I'm going to debug this code. So don't worry about that. That happened because of the previous session. And something else that I forgot is to add a delay. So remember, you have to add a delay function, maybe for a minimum of 1 milliseconds. So remember, in her library you cannot it does not implement a delay of less than 1 millisecond. So I'm going to build this and then debug the code. Then go ahead and remove all these expressions from here, and I'm going to add another live expression, which is sine angle. So I'm going just to copy this and add, and then you can also add angle, and then apart from the ITM console, remember now we are not printing to the console. We go to window, then go to show view, then SWV, and then we have this data trace timeline graph. So we are going to select that graph, add in the SWITM data console. We go to configure, and now we are going to monitor the sine angle. So sine, I hope okay, let me just copy from here. So I'm going to have sine angle, then click OK. Then you can start trace, then come to this timeline graph, and then also start trace. So that's how you start the trace. Then you resume the code, and you can see we have our sine wave from this. So maybe I should have added more delay. Maybe let's have a delay of 10 milliseconds, and then we can also print the values of the angle into our let's use printf into our data console, that is ITM, and we can have angle equals percentage D, then we have angles, and then we can print this in a new line. And then let's build the code so that we can view both the ITM console and also the timeline graph. So then go ahead and build the code. And yep, there we are. So we can start running the code, and we need to check the console. We can add another angle, and then from there you come to this part. Yeah, that's okay. So maybe we can add we can go to live expression, and we can be able to view that. Then let's run this code. So angle 0, when we hit angle 0, then we go back to angle 0. Then for the serial, you can see that we have added the both the angle and also the sine. So this is where you can see which line represent the sine of the angle and also the angle itself. So you can also go ahead and remove maybe the angle and just resume, and you remain with our sine wave. So thank you guys for following up with me. If you like the video, please subscribe, share, and even like. So I'll see you in the next tutorial with other important stuff that you need to know in STM32. Bye.